Following on from the previous two videos, I'm now going to show you how to solve the problem implicitly. So here, remember, we're trying to minimize the surface area for a given volume. So we've got V, we've got H, and we've got R. We're going to vary R and then see what happens to the surface area. So there are four variables: the surface area, the radius, the height, and the volume here. We're trying to minimize the surface area by changing the R. So when you change the R here, when you change the R here, the H will automatically react to the R. So as you vary R, the H will move about. So really, H is a function of R because remember the volume is fixed. So when you change, when you vary R, the H will automatically react. So as you decrease the radius, the cylinder will get longer because the volume has to stay constant. So as you vary R, H will automatically react, meaning that H is a function of R. Okay, and then as you vary the radius, the surface area will automatically react as well. So really, as you vary R, S is really a function of R. So when you use implicit differentiation, bear this in mind, okay? But the thing is, the volume is just a constant. It doesn't react. So as you vary R here, the volume stays the same. It doesn't react to you changing the radius. Well, just bear that in mind, okay? So now, given this situation here, so the volume is given by this. Hang on. So the volume is given by this, and the surface area is given by this. Okay. So now use implicit differentiation. So differentiate this. That will then give you this. Remember, when you differentiate this, the volume is constant. It doesn't react to you varying the radius. So when you differentiate this, it's a constant. So it will become 0. Okay. Now visualize as one block and multiplying another block here. So you've got to use a product rule. Bear in mind that H is a function of R. Okay, so because as you vary the radius, the height will automatically change. And here you are varying R here. So when you differentiate this, it will give. So the product rule is differentiate this, leave this the same. So differentiate this here will give you this. Leaving this the same will give you H. And then the second part of the product rule is leave this the same, and then differentiate this. That will give you dH by dR. Remember, you're differentiating with respect to R, okay? Because we are varying the radius. And now looking at the surface area, don't forget surface area reacts to the R. So S is a function of R. So when you differentiate this, it will give you ds by dr. Okay. So differentiate this will then give you this. Okay. And then this here, don't forget H is a product. H is a function of R. So this here, you've got to use the product rule here. So using the product rule, differentiate it, it will give you this. Okay. So we've got this, and we've got this. So we're looking at this here. Rearrange this to make dH by dr the subject, and then put the whole thing into this bit here. Okay. Well, anyway, hang on. So using implicit differentiation, it will then give you this. This will then give you this. Okay. So now we need to rearrange this to make this the subject here. So looking at this, make this the subject. So, hang on, that will then, hang on, looking at this, make this a subject. So from here, jump to here, okay? So dH by dr equals this thing here, using this here, okay? So dH by dr equals this. So now we can then put this into here. Okay, so now looking at ds by dr here, yeah, so put this into here now. So that will then take you to this stage here. Okay, so ds by dr is given by this. Now now tidy up. This gets cancelled out, giving you this, and then you've got 2 2 whatever, take away 4 whatever, that will give you minus 2 whatever. Okay, so we are now currently here. So when you get to this stage here, don't forget we are now at a stage where you've buried the constraint in there, and then you've sorry, hang on. So when you're here now, we want to find out where well, set ds by dr to be 0, because we're trying to find where we're trying to find out where the gradient will be 0. So set this to be 0 here. So this thing here will become this, and then add this to both sides. That would blah blah blah. That would take you to here. So when you are here, don't forget, when you are here, we've buried our constraint inside here. Okay, and then we've also minimized it. We've also minimized our surface area. So when you get to this stage here, well, from here you can see that our cylinder has here has to the radius of our cylinder has to be half the length of our height here. Okay, so once you get to here, you should be able to understand what's going on. Okay, hopefully.